Now talk about on important topics of complex analysis. Oh, what a topic! I don't know. In complex analysis, we discuss everything else. So we start today now. But we start from basic. And previous day we also discuss some addition, subtraction, multiplication, division in this basic tools of complex numbers. Now start about here. Here's some formula about binomial formula. Oh, binomial formula today we discuss. So we discuss binomial formula. Okay, this one is too easy, I think, but easy is handled. If we handle easy things, then we also handled big one, or we handle the original, we test the originality of mathematics. Okay, if you test mathematics, you test many things. If you need to test mathematics, so start from this portion, which are too easy, and how we discuss about that portion. Okay, so I start now. Z1 plus Z2 whole to the power n equal to summation n equal to 0 to k. Okay, oh, k equal to 0 to n. Here we write here n. If we write here k, then this one is k. Okay, n equal to 0 to n, nck. Here z1 whole to the power k and z2 whole to the power n difference k. Okay, now we also proceed in this way. How we prove this one? This one is important topics. If here z1 z2 belongs to two complex number, we denoted is this in this way. So how we introduce this one? Okay, where nck equal to factorial n by factorial k multiplied by n minus k factorial. Okay, where k equal to 0 1 2 dot 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 n. Okay, now how we discuss this problem, how we discuss or how we prove this exercise. This one is one typical exercise. Also we handle this, then this one is very good for us. Okay, so how we do this? This was important topics. First we talk about for n equal to 1. N equal to 1, left hand side is z1 plus z2 whole to the power 1 equal to z1 plus z2. This one is easy things. Next we talk about right hand side. Okay, then what happened? Yeah, k equal to 0 to 1, nck z1 whole to the power k and z2 whole to the power n minus k equal to what happened here, 1c0 multiplied by z1 and z2 to the power 0 plus 1c1 multiplied by z1 to the power 0 z2 to the power 1. Here z1 plus z2. Okay, then left hand side equal to right hand side, left hand side equal to right hand side. Proof. Next we talk about let n for n equal to m, then this result hold, then the result hold. Okay, result holds. So this results is how that means we write in this way z1 plus z2 whole to the power m equal to here k equal to 0 to n m sorry n not m mck here z1 whole to the power k here z2 whole to the power m difference k. Okay, understand? Not a problem at all. So we're going to proceed further. Yes, now we also check for n equal to n plus m. Okay, n equal to m plus n. Then what happened? Then we get z1 plus z2 whole to the power m equal to m plus 1 equal to what? We have to prove this one. Okay, that means z1 if n equal to m plus 1 this one is true, then we also done. So how we handle this one is total portion and going to further discussion of that. So it is that portion and going to further discussion of that. Then here we write z1 plus z2 whole to the power m plus 1 equal to z1 plus z2 multiplied by z1 plus z2 whole to the power m, and z1 plus z2 whole to the power m equal to this one k equal to 0 to m mck multiplied of z1 to the power k and z2 to the power m minus k. Then what happened? If we obviously multiplied this one, first z1 multiplied, then here k equal to 0 to m mck z1 to the power k plus 1 z2 to the power m minus k, and again plus here summation k equal to 0 to m mck z1 to the power k whole to the z2 to the power m minus k plus 1. Okay, then what happened? Okay, then we saw about that this one equal to how much. If we put m equal to 0 k equal to 0, then the what we get here mc0 z1 to the power 1 and z2 to the power m. Okay, and again here we obtain what we obtain. We obtain k equal to 1 to m, k equal to 1 to m mck z1 to the power k plus 1 here z2 to the power m minus k. Okay, then what happened? Then again we here write here obviously summation k equal to 0 to m not 0, we also here 1 to m. Okay, 0 portions will also vanish. Then here mck z1 whole to the power k z2 whole to the power m plus 1 difference k plus this one k equal to 0, that means mc0 z1 whole to the power k equal to 0 and z2 to the power m plus 1. Okay, here if we put 0, then what happened? If we put 0, then not a problem at all, then k plus 1 is remaining same. So we do some mistake in first portion, so we erase that portion and going to further discussion of that.
we here write k plus 1, that means k plus 1 equal to 1. Okay, that means if we write k equal to 0, then this one is okay, but we not put this one here, we put k equal to m here. Okay, if we put k equal to m here, then here mcm whole to the power z1 to the power m plus 1 z2 to the power 0 plus here k equal to 0 to m minus 1 mck z1 whole to the power k plus 1 z2 to the power m minus k remaining unchanged. Okay, so there is some mistake in first portion, but we also right now. Okay, how this one is right, that means we also put here m and here 0, and otherwise portions are remaining same. So what we get, mcm equal to 1, then z1 whole to the power m plus 1 plus here we what we get if k equal to 1 to m. Okay, then what happened, that means if we write here k plus 1 equal to k, okay, then that means put k equal to 1, then here just change something, that means if we write 0, then here mck minus 1 z1 whole to the power k and z2 whole to the power m plus 1 difference k, because m difference k minus 1 means this one. Okay, m plus 1 difference k, and again this one is similar way we write this one k equal to 1 to m, here mck z1 whole to the power k z2 to the power m plus 1 difference k plus z2 to the power m plus 1. Then what happened, then this one equal to z1 whole to the power m plus 1 plus k equal to 1 to m, here mck minus 1 plus mck z1 whole to the power k z2 whole to the power m plus 1 difference k plus z2 whole to the power m plus 1. Then what happened, we erase that portion and going to be also this one is an identity in permutation. Okay, we also discuss this identity proper way, but today we also not interested on this, just to write this result. Okay, so what happened here, z1 whole to the power m plus 1 plus this identity equal to k equal to 1 to m plus 1 ck. Okay, mck minus 1 plus mck equal to m plus 1 ck. Okay, then here z1 whole to the power m and z1 whole to the power k, sorry, and z2 whole to the power m plus 1 difference k plus here plus z2 to the power m plus 1. Okay, then we erase that portion and going to further discussion of that. What happened here, we write in this way z1 to the power m plus 1, we write in this way, not in this way, here we write m plus 1 c0, z1 whole to the power m plus 1 z2 whole to the power m plus 1 difference 0 plus here summation k equal to 1 to m plus 1 ck m plus 1 ck z1 to the power k and z2 to the power m plus 1 difference k plus here m plus 1 c m plus 1 z1 to the power 0 z2 to the power m plus 1 difference 0. This one equal to m plus 1 c k z1 to the power k and z2 to the power m plus 1 difference k. Okay. Oh sorry, here this one difference m plus 1. Okay, then here same. So what we do now, m plus 1 ck k equal to 0 to k equal to 0 to m plus 1. Okay, then if we put m plus 1, then this one equal to 0. Okay, if we put m plus 1 here, m plus 1 which is here 0. Okay, something is mistake here, not a problem at all, but then this one is in sequentially we also that means denote this one. Okay, m plus 1 ck, here k equal to m plus 1 we put, then this one is okay, and if k equal to 0 then this one is okay. Okay, so what will happen, we get also z1 plus z2 whole to the power m plus 1 equal to summation k equal to 0 to m plus 1 m plus 1 ck z1 whole to the power k z2 whole to the power m plus 1 difference k. So we prove this important binomial theorem. Okay, also prove this binomial theorem. How we prove binomial theorem? By mathematical induction. Because induction shows that if k equal to 1 is true and k equal to m is, if k equal to m implies k equal to m plus 1 be true, then this implies that by mathematical induction this binomial theorem is proved. Okay, so today we stop here.